This video is brought to you by the Environmental Protection Agency. The use of any trade names or commercial products does not constitute an endorsement on the part of the Environmental Protection Agency. The purpose of the video is to provide small water systems with an introduction to the use of point-of-entry and point-of-use treatment devices as arsenic removal technologies. Point-of-entry systems and point-of-use treatment devices are technologies that are more affordable for small water systems because they are not sized to treat all of the system's water. Although the technologies have been around for decades, they have not typically been used for compliance with the Safe Drinking Water Act. When Congress reauthorized the Safe Drinking Water Act in 1996, it included a section that made it clear that point-of-use and point-of-entry devices could be used for compliance providing they were owned, operated, and maintained by the public water system. Additionally, they must be equipped with warning systems to notify water users of operational problems and maintenance needs. POU or POE equipment used for compliance with an MCL must be independently certified to an appropriate NSF/ANSI standard if one exists. This is a schematic drawing of a point-of-entry treatment system. Point-of-entry systems are connected to the service line of a building and provide treatment for all of the water that enters the building. This type of technology can often be less expensive than centralized treatment because it does not have to be sized to treat water that is used outside the building, such as irrigation water. It may be appropriate for use with microbial contaminants and when exposures other than consumption are of concern. For example, when contact with the skin may cause health problems. This ion exchange water softener is an example of a point-of-entry installation. It treats all of the water that is used within the house, but does not treat water for the outside hose bibs. Point-of-entry treatment systems are likely to be most practical for use at non-transient, non-community systems, such as schools or factories, or small community water systems, such as apartment buildings. This is a point-of-entry system installed in an apartment building in Harvard, Massachusetts. The apartments have their own well and are regulated as a community public system. The well's water is chlorinated as it enters the building to convert arsenic 3 to arsenic 5.
It then enters these four 3.6 cubic foot fiberglass mineral tanks, and each one of these four tanks has approximately 2 cubic feet of activated alumina filled, so it's about, you can see this black line, it would be filled to at that point. And there are a total of 4 tanks, 2 tanks in parallel, followed by 2 more tanks in parallel. And then you have these sample points between the tanks. These would be commonly referred to as the worker tanks, where the water first comes in contact with the activated alumina. And if these are doing their job, then if you sample at this point, you should test for 0 arsenic, or below at least the level that you're looking for.
The treated water is stored in polyethylene tanks and is pumped from those tanks into the building's plumbing system. The treatment system is sized to produce the system's maximum in-home daily demand in less than 24 hours. Peak demands are met by pumping from storage, and water for outdoor use is untreated. In this way, capital costs for treatment are reduced, but the system incurred additional cost for storage and repumping of the treated water. Point-of-use treatment devices are often installed to treat the water from a single tap in the home. It is more commonly used to treat the water for all taps within the home that are intended exclusively for consumption. These would include ice makers and ice water taps at the refrigerator. This schematic drawing shows a device that treats the water at a single tap installed at the kitchen sink. For very small systems, point-of-use technologies may be the treatment of choice because of their affordability. This graph shows an estimate of the cost of point-of-use versus central treatment for water systems of increasing sizes. While large systems can benefit from economies of scale when installing central treatment plants, small systems cannot and have to pay higher cost per month, per service connection, to support similar plants. Based on the estimates shown in the graph, the costs for point of use and central treatment become nearly identical when the system size approaches 400 service connections. Reverse osmosis point-of-use treatment devices are being used at one of EPA's arsenic treatment technology demonstration sites in Homedale, Idaho. This is a system with only 9 service connections, but is regulated as a public system because it serves more than 25 people. The system is operated by a homeowners association, and the untreated water exceeds the arsenic MCL with a concentration of 80 micrograms per liter. It also exceeds the 10 milligram per liter MCL for nitrate. Point-of-use technology was selected because central treatment was determined to be unaffordable.
We're just a small homeowners association, and we really couldn't afford what we had heard centralized water treatment cost per person per head.
Reverse osmosis was selected because of its ease of operation and effectiveness for removing both arsenic and nitrate. It should be noted that the state was very reluctant to allow the use of point-of-use devices at the Homedale system because of the high nitrate levels.
The arsenic is free-flowing, it's everywhere. Nothing makes it more, nothing makes it less necessarily. Whereas the nitrates came from a feedlot that was here in the 50s and the 60s.
Most state regulators would prefer to have all the water in each home treated.